Hey, algebra. So this is Mr. Johnston here, and we're going to continue our pre-algebra review today. Super fast journey through a couple of really important topics. Today, learning target for you is that you'll be able to multiply and divide fractions. And actually, we're going to focus in a little bit more than that. We're actually not even going to look at dividing today, so I'll just see if I can get this crossed off. Today, we'll just focus on the multiplying of fractions, although there's not much that's different. So first of all, anytime you're dealing with fractions, we always want to reduce your fractions or simplify fractions. Those mean the same thing, and that really is kind of a ground rule for anything we're doing with fractions. So whether we're multiplying, dividing, you just always reduce. And in order to multiply fractions, there are no special requirements. I know a lot of times we get into fractions, we start thinking about like all these different rules and um, and there's certainly, I mean, there are fractions, the rules about fractions, but they really don't apply to multiplying. So like common denominators and all that stuff, that has nothing to do with multiplying and dividing. Um, so no special requirements. You have two fractions, you multiply, you're going to multiply them. You multiply the top times the top and the bottom times the bottom, um, and reduce if possible. You can't always reduce fractions, but if you can, do it. All right. Well, so let's take a look at a couple of example problems from our WAMAP. Um, the first one here says to simplify the fraction, so it means the same thing as reduce. So I got negative 10 over 16, and type my answer in here. So negative 10 over 16. The thing I want to do here to reduce is ask myself, are there any numbers that I can think of that will multiply into 10, that will multiply into 16? I'm going to go back to my times tables and think, hey, do 10 and 16 show up someplace in the same row of my times tables? I can either do it by memory or I can look at a times table. But I remember that 10 and 16 both show up in the twos row, right? 2 times 5 gives me a 10. I'm going to use the dot to represent multiplication. And 16, that's 2 times 8. Oh, this is a dot. Yikes. Okay, I can't forget this negative sign. It's supposed to be on the 10. I got it off kind of weird there, so I'm going to keep track of that. Okay, so you can take one way of doing this is certainly not the only way, but one way to keep it written down and organized is you can break those numbers apart into smaller multiples, 2 times 5 and 2 times 8 on the bottom. And this negative sign we can just treat as one more uh, thing that is being multiplied. It's like a negative sign, a 2, and a 5. Okay, well, since I have 2's on the top and the bottom, let me change colors. This 2 and this 2, they like cancel each other out. It isn't really canceling, but if you think any number divided by itself, 2 divided by 2, that equals 1. So if I divide those out, it gives me a 1, which is not going to affect anything. So I'd be left with a negative sign and a 5 on the top. And on the bottom, I've got that 8. All right, so I have now reduced this fraction as much as possible. It's negative 5 over 8. Okay, I'm going to go back over here. So how do I type a fraction into WAMAP? The first thing I want to mention is when you click on here, a toolbar shows up, and so that's obvious. I've got a couple of different things I can do as far as entering fractions. You can use the keyboard if you want. You don't have to use the little toolbar that pops up, but I want to do a fraction, so I'm going to click on the fraction here in just a second. Before I click on that, just a word about the negative sign. You know, the location of negative signs sometimes can be confusing. It does not make any difference if you write a fraction. I mean, these are obviously not the same, going to be the same answers, but just paying attention to the negative sign, it doesn't make any difference if you put the negative sign out in front of that whole entire fraction. So this looks like negative fraction, and then the fraction is 10/16. But that means exactly the same thing as if I move the negative sign and clearly put it on the numerator. So this is like negative 5 over 8. Okay, the location of that negative sign doesn't make any difference, right? Really, the thing that matters is how many negative signs are in there, like we talked about yesterday with multiplying and dividing negative numbers. If there's only one negative sign in there, it's going to give me a negative answer. So whether the negative sign is on the entire fraction or whether that negative sign is on just the numerator, it's going to give me the same result. WAMAP doesn't care. I don't care. Nobody cares. Okay, so we have a negative sign that's going to go in there. Let's get this fraction typed. Okay, So the point is I could either type the negative sign first and then click on the little fraction icon in the toolbar, or I can click on the fraction icon first and then put the -5 on the top and the 8 on the bottom. Since I haven't finished typing this fraction yet, it says it's not a valid fraction. The syntax is incomplete. This means I haven't finished typing my answer yet. So once I get that 8 in there, that error message is going to go away. It's going to tell me, yeah, your formatting is fine. And now I can submit that question. Yay, got it right. Okay, so forward and backward arrows, you can navigate through the assignment this way. Drop down menu, you can see all of the questions in here. There's 15 questions. It'll show you the score. So the green check mark means I got it correct, full credit. Yay! It's got the point values here. I got 1 out of 1. I can reattempt the problem, and this one means I can generate some new values, and I can attempt a similar problem. Right, so I can use the drop-down menu to navigate. I can just click on question 2 here if I want. I can click on the next arrow. It's going to take me to the same place no matter what. Okay, so some more work on simplifying fractions. So write each of the following as a fraction or as a mixed number in simplest form. I mean, to be honest, we don't do a lot of work with mixed numbers, but we do need to be aware of how they work and what the purpose is. They definitely have a place in math. Do not use improper fractions as an answer. Okay, and so that is a direction on this problem. For most of the year, that is not going to be a direction. Most of the time, it will actually be better, and I will encourage you to use improper fractions rather than mixed numbers. But that comes later. So we got to follow the directions as they are written. So I'm just going to do a couple of these. The first one, I'm going to do this like the same approach that what I just did on the previous question. Thinking about my times tables, I know that 7 multiplies into 35. It's 35 times 7 times 5 is 35, and 7 times 7 is going to give me the 49. So I can take the 7 away and leave the 5 on the top. And since it was 7 times 7, I get rid of one of those 7s to cancel out 7 on the top. So 5 over 7. Okay, so for mixed numbers, it's going to be a little bit different. Um, so since this starts as a mixed number, and I want to leave my answer as a mixed number, this 9 in the front is not going to change unless the rest of the fraction had an improper fraction in it, and then I would have to do some moving around. Okay, but so the 9, that whole number is going to stay put. I need to reduce this part, the 9/27 portion, right? And so I remember from my times tables, these are both multiples of 9. I got 9 times 1 on the top, 9 times 3 on the bottom. If I get rid of both of those 9s, it's going to be 1 over 3. So how do I type that? I'm going to do a 9 first. That's the whole number from in front. And then I can hit a space. And now I can put my fraction in there. I got 1 and oops, down here, 3 down there in the bottom. I think the space actually is optional, but it keeps it cleaner for me. Just make sure that I didn't accidentally get something typed into the wrong place. Okay, I am not going to hit submit because I have not actually answered these other 2 questions, but I just wanted to give you an example of how to get things typed in here and what to do. So with these mixed numbers, again, the whole number part, whoops, the whole number part right there is not going to change most of the time. Okay, jump down here to question number 7. So we got a couple of different problems here that involve zeros. So we need to remember what the parts of fractions mean, right? So anytime I have a fraction, it's got a numerator on top, denominator on the bottom. Oops, denominator. My fraction line is not big enough. Okay, so a denominator, that's the bottom number, that tells me the value of the fraction, right? If you think about the word, probably don't ever think about this word, but the root word for denominator is like denomination. Like when we talk about different currency values, you got like a $1 bill, a $2 bill, a $5 bill, a $10 bill. All of those things are worth different amounts, right? You don't just look at how many pieces of paper you have in your wallet. You got to look at how much they're worth. That's called a denomination, right? It tells you how much that piece of paper is worth. This is worth $10, and this one's only worth $1. Okay, so fractions are like worth different amounts. It takes different amounts of them to create one whole thing. Those are just telling you the value of the fraction. The numerator, or the root word here, is like number. It's going to tell you how many of them you have, right? So if we're thinking about, if I had the number 3/4, right? The 4, the denominator is going to tell me it takes 4 of these things to create one whole entire piece. But I don't have just 1/4. The numerator tells me I have 3 of them, right? Okay, so that's important for this question because it is not possible to have 0 as a denominator. That just doesn't even make sense if you think about it. If we said, as an example, 3/0, it's hard to say in the first place, but you can't have a situation where it takes 0 of something to create a whole, right? If it takes 0 of something to create a whole, it's like, I don't even know what that means. I can't get my head around what that. It's not possible, right? So anytime you have a 0 in the bottom of a fraction, that's mathematically impossible, and that answer does not exist. So we've got this little clue here. It says write DNE if the answer does not exist. Okay, so that's going to apply anytime I've got 0 as a denominator. On the other hand, I can't have 0 as a numerator. Oops. Right? If we're talking about quarters, I have a denominator of 4. Is it possible to have no quarters? Yeah. I mean, I don't like not having quarters. I would rather have quarters than not have quarters, but it's possible to not have any. So 0 in the numerator, thus mathematically speaking, that's not a problem. If we're trying to use a vending machine, having no quarters is a problem. Okay, so simplifying. 0 thirds. Well, it doesn't matter how big the fraction's value is. If I don't have any of them, simplifies to 0. So I would just type 0 for this one. Yay! Go to the next problem. So now I've got 0 as the denominator. It is not possible to break something into 0 parts and have 0 represent the whole. So I'm going to type the letters D and E in here. You can use lowercase, that's fine. You can use uppercase, that's fine. Sometimes, not for this particular problem, but sometimes when you click into the box and like that toolbar shows up, sometimes DNE is one of the options you can select out of that toolbar. That was disabled for this problem, so you're gonna have to actually type it. All right, so there's that one. Okay, so let's look at multiplying now. So I've got some multiplication problems. Starts at question 9. Multiply 1/2. Sorry, that is not what it says. Multiply 1/6 times 2/4. All right, so to multiply, remember there are no special requirements, so just do the top times the top and the bottom times the bottom. At the end, I'm going to reduce if possible. So 1/6, 2/4. All right, so I'm going to multiply top times top, so that'll be the 1 times the 2. And then after that, I'm going to multiply the 6 times the 4. That'll give me the bottom value. Change my pen. Try to change my pen. Don't want to write with the highlighter. Come on, computer. Okay, let's go back to pen. Great. So my pen's still not working. Come on, pen. You're making me impatient here. All right, let's try this now. Equal. There we go. Okay, so 1 times 2, that is 2. And then if I multiply the bottom, 6 times 4, that's going to be 24. And I got to think about reducing. Can I find any number, or sorry, any row in my times tables where 2 and 24 both show up? Or you can think about it differently, what number will multiply into 2 and 24? Well, 2 goes into both of them. 2 multiplies by 1 to get itself, and 2 multiplies by 12. Okay, so equals 1/12. Gives your answer as a fraction, reduced to lowest terms. That is exactly what I did. If you don't want to use the toolbar, let me just, there's what I was talking about a minute ago. So sometimes the DNE will show up as an option. You could just click that. That's not actually the answer I want in this case, but there's my demonstration. If you wanted to type this in as a fraction rather than using the toolbar, for some people you find it faster, and so you'd rather do that, that's totally fine on the keyboard. I can't make this toolbar go away, but on the keyboard, I'm just going to type the 1 and then the slash. We just type that, and it's going to look just like a fraction. It does the exact same thing as far as the computer is concerned, but I just hit that slash button, the // button that's the bottom right side of the keyboard, and then I can type 12. Make that toolbar go away so I can hit submit. Yay! All right. Jump here to number 12. What if there are 3 fractions? All right, well, 3 fractions does not make any difference. I still am going to Yikes, what is that? Delete. Rid of that. Okay, sorry about that. 6. Gotta pick my pen up. 5 fourths. 7 thirds. All right, so I'm gonna multiply straight across the top. 1 times 5 times 7 is gonna give me my top number, my numerator for the answer. And I guess we're working in blue and green this time. The 6 times the 4 times the 3, and multiply those together. That will give me my denominator for my answer. Okay, so already said mental math. 1 times 5 times 7 is going to give me 35. And I'm going to go backwards because it's going to be easier mental math. 3 times 4 is 12, and 12 times 6 is 72. Because yeah, I know 12 times 6 mentally. If I had gone the opposite order, 6 times 4 is 24. 24 times 3, that's a little bit harder for me to do mental math. So you can multiply forwards or backwards. You can jump around and do it in whatever order you want. It doesn't make any difference for multiplication, so that's totally fine. Let's see if we can reduce this. So 35 and 72. Can I think of a number that will multiply into 35 and also multiply into 72? The only numbers I can think of that multiply into 35 are 5 and 7 and 1. 1 is always going to be true, but that never helps me reduce anything. I can multiply 1 into 35 and also into 32, but if I reduce by 1s, I get the same answer, so that's not ever going to help. Let's see, 5 does not go into 72. 7 also does not go into 72. So I thought it through. I checked possibilities. Nothing works. So this one does not actually reduce any further. So 35 over 72. Click that toolbar away, hit submit. Yay. Okay, and then the last one I wanted to look at right now is, oh my gosh, negative numbers show up. So negative numbers, just like we saw yesterday, multiplying positives and negatives, we just use that same rule we talked about yesterday. So let's look at the negative part first. So negative 12 sevenths and negative 7 20-seconds. Oh man, I picked a bad problem. I don't know what 7 times 22 is. I have to do this mental math. Okay. Okay, so let's look at the negatives first. I have a negative over here. I've got another negative over here. Altogether, if I'm counting in my multiplicands, how many negatives show up? There's 1, there's 2 negatives show up. Anytime I have an even number of negatives, I know my answer is going to be a positive answer. Okay, so if I wanted to just deal with it this way, this is not the only option, but I can just say, you know what? If I have 2 negatives in this multiplication problem, I know my answer is positive, done. Okay, now I don't need to worry about the negatives anymore because I did them. I know that I'm going to get a positive answer. Right, so equals, and I've already addressed the fact that it will be a positive answer. Now I can just look at the numbers. So still multiplying straight across the top. Let me get this back to a different color here. Okay, multiplying 12 times 7, that is it's 84. If I can get it to right, that's totally an 8, right? Oh my gosh, what is happening? Okay, 12 times 7 is 84. And on the bottom, I'm going to do 7 times 22. Oh, we'll do purple. I haven't done purple yet. Okay. Oh, I am not sure. I said to do this as much as possible with, whoa, what's happening? I don't want it that big. 7 times 22. As much as possible, we want to do this without fractions. 154, without fractions, without using a calculator. I'm breaking my own rule here. This is terrible. I don't want to make this video even longer while I try to figure out mental math for 7 times 22. And to say in general, you should know your times tables up to like 12, but 22s, I mean, nobody knows times tables up to 22s. Okay, so I'm going to try to reduce. When the numbers get this large, I think you're fine to use a calculator. We're going to have to use our brains to some extent. We're going to try to figure out how to reduce 80 84. There's 84 over 154. I don't know my times tables up to numbers this large, so I'm gonna have to look at other ways to break this apart. I know that 84 ends with 4, that's an even number, and 154 ends with 4, which is also an even number. So I know for certain I can divide both of these numbers by 2. So I'm going to start with that. Divide by 2. Wow. Divide by 2. This was a 2. Okay. So 84 divided by 2. Then it's going to reduce this one step at a time. I'm going to have to do this multiple times, but that's what I've got. See, which is 42. And 154 divided by 2, that's 77. See, I can do mental math. Okay, and then and reduce this is if I can, I'm going to try to find some more things that I can divide both of these numbers by. And I see one because I know it's 77. That's 7 times 11. I recognize that out of my times tables. 42. That's 7 times 6. So if I divide both of these numbers by 7, this will reduce. Get some more space. All right, so it's going to be 6. And on the bottom, 77 divided by 7 is 11. 6 over 11. All right, so this is super easy for me to look at and evaluate. Can I reduce that anymore? I know 11 is a prime number. The only thing that will multiply into 11 is 1 and itself. So 6 over 11 is not going to reduce anymore. So there's my answer. Multiply, it said the directions, write your answer in lowest terms. This is another way of saying the same thing. It means to simplify or to reduce. So 6 over 11. And since there were 2 negative signs in here, and it's an even number of negatives, that means I'm going to get a positive value. If I wanted to write a plus sign in front of here, I could. It's unnecessary. I don't like to type things if they're not necessary, so just go with 6 over 11. Yay! Awesome. All right. Well, that is the lesson on multiplying fractions and reducing fractions.